Hi everybody, Matt Morgan here. In this lesson we're going to talk about formal charge from Wiley's section 9-6. We'll start by reviewing what we know about Lewis structures, how to draw them and why we draw them. We'll go into the purpose of formal charge, how to calculate formal charge, and then do some examples with carbon dioxide and phosgene. So we draw Lewis structures to figure out what the bonding is. We want to arrange the valence electrons. We want to make octets around all the atoms. Lewis structures tell us what kind of bonds exist in a molecule, whether it's single or double or triple. And we can also use the Lewis structure to help us determine what shape a molecule has and whether or not it's polar. So the Lewis structure lesson we did before went through all the steps of how to draw Lewis structures. So if you forget that, you might want to look at that video. So you might see as you work Lewis structure problems that you encounter some cases where you can draw very different structures that meet the requirements. It uses all the valence electrons, all the atoms that need octets have them, but the structures are still different. How can you determine which structure is most correct? We drew carbon dioxide having two double bonds, one double bond on each oxygen. We also could have drawn carbon dioxide like this with a triple bond and a single bond. Each of these structures use all the valence electrons, all the atoms have octets, but obviously only one of these structures is correct. How do we know? So formal charge breaks the tie. It suggests the most correct Lewis structure when there are different ways to draw it. Formal charge is calculated by taking valence electrons minus half the bonding electrons minus the non-bonding electrons. This is on each atom. Now, rather than calculating 1/2 the bonding electrons all the time, we know that a bond represents 2 electrons, and that's a line in our Lewis structure. So what I do is I say valence electrons minus dots minus lines. We do this for each atom in a molecule. So the most stable structure has the most atoms that have formal charges of 0 or as close to 0 as possible. Some formal charges may be +1 or -1, maybe even +2 or -2, but those tend not to be the most correct structure. We want to keep the Lewis structures we want to keep the formal charges as close to 0 as possible. So let's do the formal charge for those different structures for carbon dioxide. There's the first one we drew. For oxygen, valence electron 6 minus 4 non-bonding electrons minus 2 lines, valence minus dots minus lines. The formal charge on this first oxygen is 0. For the carbon, 4 valence minus no dots minus 4 lines gives us a formal charge of 0 for the carbon. The second oxygen is exactly the same as the first. 6 valence minus 4 dots minus 2 lines. It has a 0 formal charge. That's a pretty good formal charge. That's about as good as we're going to get. Also notice how this structure follows HONC 1, 2, 3, 4. Carbon bonded 4 times. Oxygen bonded twice. That minimizes the formal charge. Let's do the formal charge for the other ways to draw that carbon dioxide. Okay, the oxygen, 6 valence, minus 2 non-bonding electrons, minus 3 lines. That gives us a formal charge of +1. Our carbon, 4 minus 0 minus 4, that's still 0. Our other oxygen, 6 minus 6 minus 1. Its formal charge is a -1. There are our three structures. There are our three formal charges. That tells us that the center structure, the one with the two double bonds, the one that follows HONC, 1, 2, 3, 4, is the most correct. Atoms that conform to this tend to have formal charges of 0. That's a very good indication of the most stable arrangement. Let's do a problem now from the Wiley reading. It's exercise 9-6C from Assessing the Objective for section 9-6, page 297 in the book. So here's the problem. In COCl2, which is phosgene, we need to use formal charge to determine whether there's a double bond between carbon and oxygen or between carbon and a chlorine. So this already tells us there's going to be a double bond. It also tells us carbon is the central atom. We'll start by drawing the Lewis structure. We have 24 valence electrons. If you're unsure of the steps for drawing Lewis structures, please review the previous lesson we did. Carbon has 4 valence electrons, oxygen has 6, each chlorine has 2. We add all that up for 24 electrons. We draw our structure, 2 electrons for each bond, 6 bonding electrons, meaning we have to place 18 more electrons and give everyone an octet. 2, 4, 6, 8, 10, 12, 14, 16, 18, plus our 6 bonding. That's all of our electrons. Carbon does not have an octet, so we need a double bond. We will first put the double bond on the chlorine. Taking one of the non-bonding, adding a bond. Now, this is a technically correct structure. We've used all our valence electrons. Every atom has an octet. Let's calculate formal charge. Starting with the carbon, 4 valence electrons, no dots, 4 lines. Its formal charge is 0. For the oxygen, 6 valence electrons, 6 non-bonding, 1 line. That has a formal charge of -1. The chlorine with the double bond, 7 valence electrons, 4 dots, 2 lines. That gives us a formal charge of +1. Our final chlorine, 7 valence, 6 dots, 1 line. It has a formal charge of 0. So there are our formal charges for the structure that has chlorine double bonded to the carbon. We'll see this again later when we compare. Let's draw the other structure. 24 electrons again. Our skeletal structure is here. Let's put the double bond on the oxygen. Calculate formal charge. Carbon is still the same, 0. This chlorine with the single bond, 7 minus 6 minus 1, 0, just like on the previous structure. Our other chlorine has a single bond, but first, our oxygen, 6 valence, minus 4 dots, minus 2 lines. The oxygen now has a 0. Our final chlorine also has a 0. All atoms have a 0 formal charge. Let's compare. Our first structure, +1, -1, 2 zeros. Our second structure, all zeros. That tells us that the structure with the double bonded carbon to oxygen is the most correct, is the most stable. Also, if we look, that follows HONC, 1, 2, 3, 4. H can be hydrogen or halogens. When halogens are single bonded, oxygen has 2 bonds, carbon has 4. That is our most stable structure. So what we did, we discussed formal charge, how to calculate it, how to use it to find the most correct Lewis structure. Work those Wiley problems. Contact your course mentors. If you have any questions, here is our contact information. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.